Hello, welcome to my channel. We will be doing question number 12 today. Okay, this is a bit challenging question, I would say. So the second derivative is given d square y by dx square, and this is equal to 4 sine 2x. Okay, the curve has a gradient of 5 at this point. Number one, find an expression for the gradient of the curve at this point. Okay, so the first part is that we need to find the gradient. Gradient is the first derivative. Remember, gradient is dy by dx, the first derivative. So we are given the second derivative. So in order to find the first derivative, we need to integrate it. Okay, so dy by dx, the first derivative, which is gradient, is going to be the integral of this part. Okay, so when I want to integrate it, it's 4, it's constant, and sine is integral of minus cosine. So I will have minus cos 2x over 2, and then I have a constant of integration, right? So this will give you, see, I can write it in the beginning, and then minus 2 cos 2x. Okay, now I can find the value of this constant by this information, that the gradient is 5 when x is pi by 2. Okay, so I will use this information. Uh, so this gradient is 5 when c minus 2, sorry, yeah, 2 into cosine of 2 into x is pi by 2. Okay, so you know that c minus 2 and cos of pi is minus 1. So it will become c plus 2. So from here we can prove that c is equal to 3, right? Okay, so if c is 3, then I have this equation that dy by dx, the derivative function, is equal to 3 minus 2 cos 2x, right? So the first part was the final expression for the gradient of the curve at this point. Okay, so we found the gradient. If I know the value of x, I can find the gradient. So this is question number one, part one. Okay, second question. Okay, find the equation of the curve. Okay, and okay, so equation of the curve means I need to find y equal to whatever, and that I can find by integrating this expression, right? So you can see y is equal to integral of 3 is going to be 3x, and minus 2 for cosine is the integral of is the integral of sine 2x over 2. So it will become 3x minus sine 2x. Okay, one thing I forgot. You see, when I find the integral, this expression, right, I want to confirm. So how can I confirm? I will differentiate this thing. Okay, so when I differentiate, the derivative of c is 0, and minus 2, the derivative of cosine is minus sine. It will become minus, and then sine 2x, and the derivative of 2x is 2, so the 2 times 2 will become 4. So yes, I got the same expression as in the beginning. So it means that, and I don't need to write it, that this integration is correct. Okay, in the same way, okay, so yes, when I will do this thing, then I will have a constant of integration as well. Let me call it d, so plus d. Okay, and just to double check, I would like to integrate this expression. So derivative of 3x is 3, minus sine 2x derivative is cos 2x, and derivative of 2x is 2, so it will be 2, and plus 0. So yes, it is the same thing as this one. It means that my integration is correct. Okay, now I can find the value of t by this information. Okay, we are given that when x is pi by 12, the y is minus 1 by 2. So this y is basically minus 1 by 2 when x is pi by 4. So 3 times pi by 4 minus sine 2 times sorry, 3 times pi by 12. My mistake. This is pi by 12. Okay. Uh, and sine 2 times x, and x is again pi by 12. Okay. Plus d. Okay. So let's simplify this expression. I have minus 1 by 2 here. Okay, equal, this will become pi by 4. Okay, 3 4 are 12, so this will become pi by 4. And then I have minus, and sine of pi by 12 times 2 is pi by 6. Pi by 6 plus d. Now remember, sine pi by 6 is also 1 by 2. Okay, so this is 1 by 2, negative 1 by 2, this is negative 1 by 2, they will cancel each other. So from here, I can consider d is equal to negative pi by 4. Okay, d is equal to negative pi by 4. Okay, so from here, I conclude that my function y would be equal to 3x minus sine 2x, and d is minus pi by 4. So this is my function. Okay. Okay. Now this is part 2. Find the equation of the curve. Now I will do part 3. Part 3 says, let me put a line here. Find the equation of the normal to the curve. Okay. So we know that the derivative dy by dx is given by 3 minus 2 cos 2x. So I need to know the derivative when x is equal to pi by 12, right? Because I need to find the uh, normal to the curve at this point P, and P is the x coordinate of P is pi by 12. Okay, so dy by dx, and when x is pi by 12, this is going to be 3 minus 2 times cos 2 times x, and x is pi by 12. Okay, so it will become 3 minus 2 cos pi by 6. Okay, pi by 6 is 30 degree. Okay, 3 minus 2 times 30 degree cos is under 3 by 2. So 2 cancel. I have my 3 minus under root 3. So this is the slope of the curve at this particular point. Okay, so since I need to find the equation of the straight line which is normal to the curve, so the slope of the normal line, okay, so this slope is going to be the negative reciprocal of this one. So it's going to be 1 over and 3 under root minus 3, right? So slope is this, and it is passing through this point, pi by 12 and minus 1 by 2. So I will use my formula y minus y1 equals m into x minus x1, and y minus y1 is minus half, so it becomes plus half, equal m is 1 over under root 3 minus 3 into x, and minus x1 is pi by 12. Okay, hope everything is clear here. So let me open this bracket. It will become 1 over under root 3 minus 3 times x. Let me put it together. Okay, and minus pi by 12 into under root 3 minus 3. Okay, and I take the 1 by 2 on the other side, so y is equal to 1 over under root 3 minus 3 times x minus pi by 12, and then under root 3 minus 3 and minus 1 by 2. And if I find the numerical values of these expression, this complicated expression, this is going to be minus 0.789, 789, this is decimal, uh, oh my God, times x and minus 0.294. You can use calculator to find this answer. Okay, so this is the final equation of a normal line. Okay, I hope everything is clear. If you ever have any question, you can ask me in the comment section. Thank you very much for watching. See you in the next video.